Hi, everyone. Welcome, and thank you for joining us for today's webinar, Improve Network Security with Application Intelligence. My name is Sarah Gross, and I will be one of the presenters today, as well as the moderator for this event. As I mentioned before, my name is Sarah Gross. I'm a product marketer for Ixia's visibility products, and I'll be presenting this webinar alongside Christophe Olivier. Christophe is a Senior Product Manager for Network Visibility and Virtualization Solutions at Ixia. He will be giving a demo of AppStack near the end of the presentation and will also be available for answering questions during our Q&A session later. Our biographies are available on the top left corner of your screen if you'd like to read more. Today we will cover automated security and its benefits. We'll go over what context-aware data is, compare application filtering and application intelligence. We'll discuss Ixia's AppStack solution and give an overview of what a full application intelligent deployment may look like. We'll also cover a few use cases before Christophe gives his AppStack demo, and we'll go into our Q&A. Data breaches are becoming a regular occurrence these days. It's in the news all the time now. And over the years, we've seen a positive progression in the number of breaches that have occurred per year. This graph is representative of the total number of breaches that were detected and reported per year, but it does not reflect the size of each breach. The Identity Theft Research Center, who provided the information for this graph, stated that they are aware that many breaches go unreported, and as a result of that, they are certain that their breach list underreports the problem. It is worth noting that the number of breaches decreased from 2017 to 2018 by 23%, and thinking about possible reasons why this decrease may have occurred. But overall, we are seeing a positive trend year over year by the number of data breaches occurring. In 2017, over 197 million sensitive records were exposed. These are records considered to contain sensitive, personally identifiable information. In 2018, the number of sensitive records exposed was much greater, reaching almost 447 million. This was up 126% from 2017. With that being said, the decrease in the total number of breaches we saw earlier, the down 23%, was misleading as it did not reflect the large increase in the number of sensitive records that were exposed and the number of individual people affected by a breach in 2018. The Identity Theft Resource Center stated that only half of the total number of breaches reported in 2018 included the number of records exposed. Because of that, the actual number of exposed records likely exceeds the reported number substantially. So they're saying that 447 million was actually a very low number representative of the people affected in 2018. With almost 447 million sensitive records exposed during the year, that equates to 85 sensitive records exposed per second in 2018. Just for fun, can you guess the most common method used that caused a breach in 2018? If you guessed hacking, then you are correct. So, given the numbers we have witnessed in recent years, a breach affecting you becomes a matter of not if, but when. And because of that, are you prepared for when a breach affects you? Are you sure you're confident in your current visibility and security deployments? Once you are affected by a breach, there will be several different costs associated with that breach, the first being detection. Costs associated with detection include activities that enable a company to detect a breach, like forensic and investigative activities or assessment and audit services. Next are costs associated with escalation. These are activities surrounding the report of a breach to appropriate personnel. This could include crisis team management communications or communications to executive management and the board of directors. Then comes costs associated with notification. This could include activities involved in notifying individuals whose data was compromised as part of regulatory activities. Examples of such could be emails, letters, phone calls, or general notices that personal information was exposed. Other forms of notification activities may include communication with regulators to determine all regulatory requirements were met, and also engagement with outside experts. Next are costs associated with the response to a breach. Post-data breach responses may include processes set up to help those affected by the breach to communicate with the company, as well as costs associated with redress activities and reparation with breach victims and regulators. Examples may include help desk activities and other forms of inbound communications, credit report monitoring, identity protection services, issuing new accounts or credit cards, legal expenditures, product discounts, and regulatory fines. And finally, there's costs associated with lost business due to a breach, which is pretty self-explanatory, but it involves activities associated with customer turnover, business disruption, and system downtime. Examples could be revenue loss from business disruption and system downtime, or costs associated with losing customers and acquiring new ones, as well as reputation losses and diminished goodwill. The total cost of a data breach can be linked to the amount of time it takes to contain that breach. IBM Security and Ponemon Institute completed their 2018 cost of a data breach study and found that a company who contained a breach in less than 30 days faced an average estimated cost of about $3 million. But on the other hand, a company who took more than 30 days to contain a breach faced an average cost of $4.25 million. This is a significant cost difference, and it makes it look like having a shorter time to containment directly affects the total cost of a breach, which it does to some extent. But what if you could reduce the cost of a breach irrespective of time containment? IBM and Ponemon actually found that companies deploying a fully automated security solution decreased their overall breach cost average, no matter how long time to containment lasted. And I will define what an automated security deployment is on the next slide. In the IBM study, automated security was defined as security technologies that augment or replace human intervention in the identification and containment of cyber exploits or breaches. So given this definition, I want to ask you, do you deploy automated security in your network today? Can you identify areas where automated security may fit? Next, we'll look at common network architectures and where automated security features such as application intelligence and automated filtering may fit into your deployment. First, I want to ask, how do you feed data to the tools you currently have? Do you send your tools everything? Sending all the data to your tools can overwhelm your tools as no load balancing occurs. It can be costly from an operating standpoint and can lead to tool failure in the worst case. So overall, it's too much data. Your tools are only as good as the data they receive, so ensuring the right data and only the right data gets to your tools is critical for both network optimization and headcount relief. For example, IT professionals today are suffering from a giant influx of security alerts. When receiving too much data, tools will send alerts that may not be true risks to the network. This forces IT professionals to comb through massive amounts of alerts looking for actual threats, often leaving many alerts uninvestigated. Putting this task on the shoulders of IT staff can cause alert fatigue and lead to overlooked alerts that legitimately pose a risk. If you don't send everything to your tools, do you filter layers 2 through 4? Maybe by type of traffic, port number, or IP address. Though this kind of filtering will decrease the amount of data sent to your tools, in general, it's still too much data being passed on. Additionally, this kind of filtering lacks real context that your tools can benefit from. Just because traffic from a certain port is being sent for analysis doesn't mean that the tools will be able to work more efficiently to identify issues or security risks. So in general, it still lacks context and it's still too much data. So, what did I mean when I said layers 2 through 4 filtering lacks context? Here I have some examples that show what context-aware data is. Data without context doesn't give you or your tools very much information to work with. You can see that a certain application is connected to a certain port. But so what? With context-aware data, not only can you find out which port an application is connected to, but you can also find out what type of application, known or unknown, is transferring files and where those files are being transferred, like an unknown application in Sydney transferring files to North Korea, or an IT-approved application in Paris transferring files to an internal server in London, or someone who has Telefonica as a service provider is using Windows on their PC to run BitTorrent remotely in Brazil. Context-aware data is data that provides context about what's happening on your network so that your tools work better. It can also help you make intelligent business and security decisions while reducing operating costs in the end. Traditionally, visibility solutions doing application filtering use regular expressions, also known as regex, which are expressions that are manually entered and defined to match patterns or strings. Regex can be a powerful tool, but it's also rather complicated and prone to errors for someone not well versed in this subject. The program generally blindly looks through all of the application data for that string that was predefined. It can lead to false positives a lot of the times, which can then lead to false alarms from your tools. And just in addition to the invalid string searches in general that it can produce, regex has a few other disadvantages that I'll cover right now. One common mistake is its precise but inaccurate match. It's where regex rules are consistently matching the same application, but it's matching the wrong application for which you intended, for which you wrote the rules. Another common error is found with applications containing the same name. So let's say you're parsing HTTP. In most deployments, it may be limited to the name field within the application or port number. If users within the same type of system define a rule to match an application name and then a new application comes to market with a similar name, there's a chance of a false positive match at that point. And another common error can be found in accidental repeat. So false positive matches may occur because the string search may accidentally reside in any other portion of the packet data, for instance, in the email subject line text files. Should all of these inconsistencies occur, tools will be collecting the wrong data for analysis. To prevent the issues with regex I just mentioned, you can deploy application filtering solutions that provide context-aware data. A true application intelligence solution meets the following criteria. It has an adaptive, uncomplicated application management platform. It has accuracy and precision in both application identification and filtering, and it updates automatically with ever-changing application signatures and new application creations. All of this leads to an improved automated security deployment, which we said earlier reduces costs. So, what can an application intelligence solution do for you? Well, bad guys leave tracks. These are digital footprints, otherwise known as indicators of compromise, that can be detected using application intelligence. Faster detection gives an invader less time to scour your network and wreak havoc. And application intelligence deployments also lead to faster containment of a breach while enhancing your automated security, which, again, we already discussed, decreases your cost in the end if you're affected by a breach. Ixia's application intelligence solution, also known as AppStack, meets all of the requirements we defined earlier and provides the deep packet inspection you need for the data on your network. It has an adaptive, uncomplicated, and intuitive application management system. It has accuracy and precision in application identification and matching. And it also updates automatically with application and threat intelligence information from a dedicated research team. All of this comes behind an easy-to-use dashboard with a drag-and-drop point-and-click interface. I'm going to explain a few of AppStack's features now, the first being its application identification technology. AppStack can detect applications through static, dynamic, or customized signatures using a patent-pending technology. This feature allows you to filter based on signature, browser, operating system, IP address, application type, or subcategory. You can choose to exclude data or include specific data that you want sent to your tools for analysis, and it does not require the use of regex. Every filter is added with the click of a mouse. This slide goes into a little more detail about AppStack's multi-level detection system. AppStack was designed to have the highest application identification accuracy on the market. To accomplish this, it uses Layer 7 protocol parsing and matching based on protocol context to identify an application. It uses all of the following approaches in order. The first being Ixia signatures, where applications are identified using definitions in XML documents generated by the Ixia engineers using tools for decoding Layer 2 to Layer 7 packet streams and combinations thereof. The next is dynamic pattern identification, where application traffic patterns are identified dynamically using Ixia's patent-pending technology. When a session cannot be identified with existing application signatures, the packet headers are sent to a special engine which identifies reusable patterns. The patterns are then stored and can be used to track new applications and to augment existing filters. Next, the user can also define regular expression or regex matching to match application types and add it on to existing filters. Also available is protocol and port number matching. Application identification is attempted in a sequential mode, starting with the first approach in this list. Whenever an application cannot be identified using a higher order approach, identification continues with the next link in this chain. The next feature I want to mention is AppStack's geolocation and tagging abilities. This feature allows you to filter data based on geographic location as well as monitor and report top applications and countries' bandwidth consumption. It allows you to quickly troubleshoot application issues for public and private locations like a specific remote site with a private IP address. AppStack can pinpoint the custom location and the application running, like voice over IP problems from a UK office. Next is the optional regex filter. I know that I mentioned some downsides to regex earlier, but sometimes it can be helpful when adding it on top of other features or other filtering techniques. You can use regex with AppStack, but it's not required. If you have the regex knowledge and ability, you can add regex filters to look for a string on top of already predefined filters to increase the preciseness of the criteria. Christophe will be showing you an example of this in the demo later. Next is Ixia's IXFlow feature. IXFlow is an extension of NetFlow version 10 that includes customizable metadata to send enriched data to your tools. IXFlow is a very important feature of AppStack. In today's world, we have a lot of data to deal with, and you simply can't look at it all or inspect all of it. So leveraging metadata to only look at a subset of the data is a more efficient process for analysis. You could even lower the amount of traffic to maybe something like 5 to 10% of the full traffic for inspection. This is super beneficial when you have so much data coming through your network. Christophe will also be showing an example of this in the demo later on. The next feature is packet capture. With the packet capture capability, it's quick and easy to set up a filter and get any slice of traffic you need from a specific country, application, browser, device, and more right at your fingertips. It's convenient for troubleshooting, configuration, and validation. The next feature is the backbone of what makes AppStack an intelligent platform. It's having a subscription to Ixia's Application and Threat Intelligence Research Center. Dedicated engineers work in the Research Center who not only focus on current and future applications, but also research malicious attacks and methods. That keeps you up to date with threat intelligence feed that can expose attackers already on your network and keep your network safe in the future. When you have the ATI subscription, your dashboard will automatically update when the ATI Research Center publishes new signatures and threat findings. The last feature I wanted to highlight, but certainly not the least, is this next feature. Threat Insights is the newest feature we've added to AppStack. The threat intelligence feed from the ATI Research Center that I mentioned before is put into use into Threat Insights. It provides a map view of threat information from a geographical standpoint, as well as a list that tracks detected attacks or suspicious activity. Threat Insights can send threat information automatically via NetFlow to existing security appliances if you wish, and Christophe will be showing an overview of Threat Insights in the demo later. This diagram shows a general overview of what your overall solution could look like. AppStack comes on our network packet brokers like the Vision 1 or Vision 7300, and it also comes as a virtual appliance. Basically, you have data come to your packet broker. The data would be processed with aggregation, decryption, deduplication, header stripping, line rate filtering for layers 2 through 4, time stamping, and more great processing capabilities of packet brokers that I don't really have time to discuss today. As part of that processing, though, the packet broker would use AppStack to deploy layer 7 filtering and the other features that I just described. If you wanted to block that threat information from Threat Insights, then you could also deploy Ixia's Threat Armor, which would automatically block the known malicious activity and threats from entering your network. And once your packet broker has finished processing and filtering the data, it would be passed on to your security and analysis tools so that they're receiving the right data at the right amount. The packet broker can load balance based off of capacity. If you happen to have a Vision 1 today, then there's also a free AppStack dashboard already loaded on your system. And we are having a special free trial for the ATI subscription I mentioned earlier that you could deploy if you so wished, if you already have a Vision 1. I'm just going to cover some general use cases now for AppStack. It's not an exhaustive list of all the use cases, but it offers some good insight into how you could benefit from AppStack as a solution. So first, you could detect a phishing attack using Threat Insights. It can tell you who's involved and targeted, as well as how they're visiting a malicious link. And because you're able to detect this threat early on, you can expedite the detection and containment process, which leads to less cost from a breach. You can also use Threat Insights to detect any attack early, which means that later on you don't have to experience a huge breach just to show you that there's something wrong with your process. So by using Threat Insights, you're able to become more proactive in your security and breach practices by influencing necessary change. Employees can become more educated against future attacks, and your current processes could be tested and updated as needed. Use case number 2 is the optimization of your current security and analysis tools. This is just one example, but AppStack allows you to filter out specific application data, such as video streaming traffic, so that it's not included in the data being inspected by your tools. And by doing this, you get to reduce bandwidth to your tools, which can then reduce operating costs and help expose actual threats in the end. And like we discussed earlier, alert fatigue is a real thing amongst IT professionals. So being able to send less data to your tools means that less alerts are generated. And because of that, less time is spent looking at false alarms time is spent investigating actual threats. The last use case I have for you today is using AppStack to pinpoint network issues. When IT tickets are coming in hot, you can improve your mean time to resolution by automatically collecting the necessary user details that you need to complete the ticket, as well as deploying layer 7 filters that can drill down to determine the root cause. Is it a specific device type? Is it a particular application? Or is it something else that's causing your network to slow down? This can help you focus on moving forward as opposed to backwards. Your support teams would be able to solve more on their own without having to consult a development or a launch team. And if those teams do need to be consulted on some type of issue, then they'll have all the details they need readily available to solve the issue. And also it would reduce the amount of repeating IT tickets that continue to waste time. So that's all for the use cases I have today, and then we're going to move on to Christophe's demo. He recorded this video ahead of time for this event to show you an overview of the AppStack dashboard.
Hi, this is Christophe Olivier, and I'm going to give you an overview of AppStack. The dashboard is not the main functionality of the AppStack product, but it will give you a useful overview of what's happening on your network. The dashboard is built with several widgets which give the traffic information. You see it here on the upper left corner, application distribution, top threats, top countries, a word map of the activities, the dynamic apps. Dynamic apps are the applications which are detected on the network but which we don't have the signatures for. But that means that you may need to investigate them because they are on your network. The top devices, top service providers, browsers, top filters. For each of the widgets, you can, of course, expand them and you can change the time range. Just clicking here and selecting, for example, the last 5 minutes and save. This can also be done at the widget level. As I mentioned, the main feature of AppStack is not this dashboard. It is the deep packet inspection and what you can do after inspecting the traffic. You can define filters and send that traffic or a portion of that traffic to the tools, the monitoring tools of your choice. You can generate metadata in form of NetFlow, or I should say advanced NetFlow, enhanced NetFlow, that we call IXFlow, which is based on version 10 plus 40 plus custom fields. You can do some data masking if you want to hide some of the information that you're going to forward to the tools for confidentiality. You can do reject searches. So let me show you that. But before I start, here on the left, we have the available network processor. So this system only has one network processor, which is green, which is good. Some of our packet brokers have up to 6 network processors, and you would have here a list of six network processors that you can assign as different resources. But before we jump into filters, I would like to introduce you to a cool feature that we introduced last year. It's called Threat Insights. Let me expand that threat summary widget. The default view when expanding the widget is the map view, which gives you at a glance the threat activity on your network. In that map view, you see that on the bottom left, we have the legend. The more red the country means more threats coming to that country or coming from that country, and the threats differentiated by colors. At the bottom, we have that long table where you can click on one of the entries to get additional information about that threat. We call that information the rap sheet information, which is pulled from the Ixia threat intelligence database. Depending on what you click, you will of course see more or less information in that rap sheet. In this example, we have whatever we know about that phishing attack. You can click on that picture to expand it. The filter view gives you another level of details on those threats on your network. You see at the top here, you can define different filters. The threat information is sorted or represented by bar charts. The longer the line, higher the number of sessions. If I hover on that malware blue line, I have 9,149 sessions. If I click on exploit, I have no exploits and the table is empty. Same as in the map view, if you click an entry, we pull the information for that thread from the threat information database. You can send the threat information, category, and IP address via Ixflow to the NetFlow collector of your choice. Back to the filter definition. Let's say that I am a customer and I have a lot of YouTube traffic on my network, and I would like to drop that traffic so that it does not flood my monitoring devices. I just go to Applications. I can select by categories, but I can also do a quick search here. Search for the YouTube traffic, check YouTube and YouTube Remote. They display here. And decide from there what I want to do as a traffic egress action. And just check drop, save that filter, call it YouTube. As you see, the new filter is now available on the left pane. And if I click on it, I will get the statistics for that filter. There was already some traffic after just a few seconds. Note the action, drop, and it's also possible to generate a pcap by just starting the pcap from here. Now, let's look at the different use case. For example, you want to create a filter which is going to look at the traffic between the US, Russia, and China. Did I say the email traffic? So let's look at emails. Here in that category, I can select email, and the email, there are subcategories. I'm going to pick Gmail, SMTP, and SMTPS. Do create a regex. So for those emails, I want to look at traffic that includes fireworks, very original for China, of course, and bang. Not sure what I'm going to catch. Okay. And with that traffic, what do I want to do? I want to forward it to VLAN number 2. That's where the packet broker will send it. And I want to save it as fireworks. Here we have our fireworks filter. There is a third option that I would like to show you. It's about metadata generation or NetFlow generation. First thing before creating the filter is to enable NetFlow. As you see here, that small icon NF is not green, and I need to enable my NetFlow feature. So it can be done either by clicking that wheel to access the page or just clicking that icon. I access the page and I am enabling NetFlow. I just need to select which NetFlow I want. To illustrate what we can do with Ixflow, we need to check that box here, enable Ixflow. And these are the fields which are available for you to export. If you want to add thread types and thread IP, just check those boxes and save that. At the bottom here, I have 2 NetFlow collectors defined. One is active, one is inactive. You can easily enable it. And here, this is something you can also change, is the sample rate. By default, there is no sampling, but if you want to sample, you can set that to 50%, for example. Or if you don't want to sample, just change it to whatever you want. And now we can see that NetFlow is enabled. And it's ready to be used in a filter. For this NetFlow generation filter, I am going to select the traffic, email traffic between Canada and the US. And instead of selecting sub-email categories, I am going to pick the whole email category, which includes everything. And as the egress action, just go to traffic egress actions, click NetFlow, select NetFlow, and select which collector I want to send it to. First one, second one, both, up to you. You may have some traffic that goes to certain tools, some traffic that goes to some others, up to you. This is just an example. Give it a name. And here we are. Our NetFlow filter is now operational. And as you see, it started generating traffic. You can see our newly created features on the left here, and as well in the top filters for the last hours with some associated statistics. And I cannot believe that the fireworks filter, completely made up, is picking up some traffic. Oh, something I forgot to mention. I'm not going to do the details, but you can also enable SSL decryption if you want to see what's happening in encrypted traffic, because today a lot of traffic is still is encrypted, and if you want to see what's happening in that payload, you need to decrypt it. So you need to enable SSL decryption. We can do that, as well as packet modification, also called data masking. If you want to mask credit card information before forwarding that traffic to the monitoring tools of your choice, you can do that from here. So you check that, you can create your new payload mask and associate an egress action. This concludes our demonstration. I hope you enjoyed it. Thank you for your time.
Thank you for that demo, Christophe. Now I'm going to move on to a conclusion. If I wanted you to take away just a few things from this presentation, it would be some of the following points. First of all, a data breach is going to affect you at some point, and it's inevitable. And once that time comes, are you prepared? It's been shown now that automated security deployments can reduce the cost of a data breach. Do you deploy any automated security features in your current architecture? And finally, Ixia's app stack can be a part of your automated security deployment so that your breach costs are minimized. It meets all of the requirements of a true application intelligence solution with its intuitive application management dashboard, its accuracy and precision, as well as its automatic updates and threat information supplied by Ixia's ATI Research Center. Now, if you want to submit any more questions before the Q&A session, go ahead and do that. In the meantime, I want to direct your attention to our resources we have available so you can find out more about ACK and application intelligence. You can click on the little paper icon on your dashboard to access the resources. Today I'm highlighting just a few resources, a case study, a white paper, and a solutions brief that I think you should check out. As a reminder to the audience, you can submit your questions using the Q&A button, and if we don't get to your question today, we will answer it via email afterwards. I did see some questions come through, so we're going to get started with the Q&A. I will be asking the questions, and Christophe will be providing response. So the first question, do I need to learn any scripting or language to define filters?
No, you don't. And as you saw in the demo, you can quickly build a very powerful filter with just a few mouse clicks. If you want to add regex to your filter, that will require a little familiarity with how to write regex, but you have plenty of examples and help provided, so not a big deal.
And is AppStack a monitoring tool?
The short answer is no, and as you saw also in the demo, AppStack offers a dashboard which provides an overview of your network activity at a glance. You can do packet captures. So the kind of things that you do with a monitoring tool, but AppStack is not a monitoring tool by itself. Typically, it feeds third-party tools. We work with tool vendors, NetFlow collectors as kind of partners. And the power of AppStack is that it's very easy to create layer 4 to layer 7 filtering capabilities or filters. And so the dashboard is here to help you, but the big part of AppStack is actually hidden behind the scene. It's its engine, its DPI engine, its filtering capabilities.
Gotcha. Okay, next question. I don't really see how AppStack is going to help me with security issues. Could you please explain?
Yeah, that's a very good question. The whole point of AppStack is to easily find indicator of compromise, what we also call IOCs, that bad guys would leave behind them on your network or on your systems. And most importantly, it's to find them as quickly as possible. And you saw when Sarah presented her slides that speed is really the matter. The cost it will have, the longer you take, the more expensive it will get. Most data breaches take several months to be detected. And during that time, the hackers have plenty of time to damage or to steal or to do whatever they want on your network. AppStack will help and will report secret information over AXFlow by many extensions that we provide on top of NetFlow. We call that AXFlow extensions. It's 45 plus extensions, and they include information about URI or URL, user agent information, what kind of browsers your users are using, DNS text field information, geolocation, threat information. And this information can be used by the technical partners that we work with or by your tool providers to speed up the detection of suspicious activity. And they can quickly focus on, for example, file transferred out of the country. You say, oh, wow, am I supposed to do that? Or are we supposed to do that? Or data leaking out of the company via HTTP or DNS, which are two common ways to leak data, or malware connecting to botnet controllers. So all kind of use cases that you can quickly spot.
Awesome, thanks. Next question. How can AppStack help me save on my security tool bill?
Another good question. I tried to illustrate this in the demo with when I created that YouTube filter. Let me give you an example. Let's say that you are a university, you have 100 gig network links, and you want to use IDS tools for security inspection. But you know that about half of your traffic or of your network bandwidth is consumed by streaming videos, Netflix, YouTube. It's a university, so and that traffic does not need to be forwarded to your security inspection. You don't care about that workload. So what AppStack can do, it can not only allow you to select that kind of traffic and work with it, but it allows you by selecting drop in the egress action, as I did in that filter, to just ignore that traffic. So that's 50% of the traffic which will not be forwarded to those tools. And then that will lower that that bill, of course.
Yeah. Awesome. Thanks. Next question. Which application signature is supported by AppStack?
So AppStack provides a list of, I would say, the most common application signatures, and new signatures are developed and added on a regular basis. And but there is also another very useful feature, and I don't remember if I showed it. I think I mentioned it, called dynamic applications, which we show in that dashboard. Those dynamic apps are applications which are not recognized as known signatures, so they are not in the provided list, but that does not mean that they are not important, because the system or AppStack sees them, which means that if on your network you see applications in that list, even if they don't have a known signature, that probably means that you may want to look at those or dig a little deeper to see if they are supposed to be on your network. And so once you spot something of interest, you can select that application and create a filter for that application and do what you want with that filter. But that will allow you to do more digging. Where is it coming from, or where is the activity coming from or going to? Which IP address is it reaching? Is it reaching out of the country? Is it reaching non-threat servers? That kind of thing.
All right. Thank you for answering that. And then we are almost out of time, so I think this will be our last question today. But could you please explain more about threat insights?
Oh, sure. I'm glad you're asking. And then Sarah mentioned it during the presentation, and I believe that I also showed you a few screens during the demo. But I'm glad you asked, because I think that this feature, which was introduced last year, is a very good feature, a very useful feature. It leverages the Ixia well-known threat intelligence database, which maintains a very large number of known threats on the internet, and we can detect if those threats are present on your network. So AppStack will categorize them as malware, phishing, IoT botnet, hijacked IPs, and will export them, or will allow you to export them to your NetFlow collector, a NetFlow collector of your choice, and some support those additional fields. And how can you use that? Threat Insight can, with this feature, can help you to quickly spot a breach and detect malicious activity. For example, you can spot quickly multiple internal systems connecting to a bad IP. And that bad IP being flagged as a threat, that would be a good warning for you to decide to dig a little more on that. Another use case would be to look for calls to internal systems which are accessible to the internet, like IoT systems. And sometimes those systems use weak user ID and passwords, sometimes even static passwords, like security cameras or those kind of equipment. And if a hacker can access them, God knows what they're going to do with them. They can reroute the stream. They can exploit that. So that's an area where you may want to use that to dig there. And you can ask yourself the questions: are those systems supposed to be accessible from the outside? If yes, are they well protected? So that could be the beginning of a reflection process. And maybe another use case, and Sarah said we don't have that much time left. You may want to look at phishing attacks. Who is involved? Who is targeted by those phishing attacks? Are they always the same kind of people, or is it a specific department? Why are internal resources visiting some of the sites which are flagged as phishing? So that by better understanding why your users do that, that may allow you to provide better education against social engineering, or do you already have those features, those procedures in place? So, I'm kind of making this up as we go, but you see, it's not a limiting number of use cases. You can really leverage that, and I think that's enough for a short answer.
Okay, great. Thank you so much, Christophe.
No, thank you. Thanks everyone for listening.
It looks like we are out of time for the Q&A session. A big thank you to our audience for your participation and interest in this topic. You can check out the resources widget to access the documents I referenced earlier, and you can also download today's slides there. I would like to encourage you to fill out the survey by clicking on the clipboard icon. Even if you're watching this on demand, you can also fill out the survey. Please visit our website to get additional information on network visibility and security, or just to check out our other upcoming webinars, and we hope to see you at a future event. Thanks again, and I hope you have a wonderful day.